is geometry. It'll let me write. Review. What is this? 1 through 25. Part 1. I'll try to cover as much as I can. We don't have a whole lot of time here. I think we've got about 20 minutes. Your first question is a question that you've seen on a test before. Okay, so I'm going to show you what the question looks like, but beyond that, I don't know how in-depth I want to go into it. All right, it's going to give you something similar to this. In fact, I think you saw this question even on your review. I think it was number 9 that was maybe cut off. All right, so you saw like G, H, K, say A, B, C. I know those aren't the letters, but they're going to ask you a question along the lines of if I wanted to know what A, H, K was. Now, they're not going to highlight that in blue like I am, but one thing that they are going to tell you, they might tell you that this is, well, they'll tell you that that's, say, 34 degrees, and they'll tell you that AH, okay, ray AH bisects angle GHB, okay, and you need to find angle AHK. Okay? How do we go about doing that? Okay, so you started with 90, right? That's an angle that we know. We've got a right angle in there. So we've got 90. 90 and 34, so we've got 90 and 34 are degrees that we know that are there, so that comes out to what? 124. Okay, so we've got 124 degrees from here to here. We just don't have the whole thing. Okay, so we know that all of the way across would be 180 degrees. So we can subtract 124 from that, 56. All right, that's going to give me 56 degrees. Now, what is 56 degrees? GHB. So GHB is 56 degrees. All right, so take 56 and divide it by 2 because, why divide by 2? How do I know that I'm dividing by 2 here? Because AH bisects it into 2 equal things. So what's 56 divided by 2? 28 degrees. So what is 28 degrees? AHB is 28 degrees. And GH8 is 28 degrees. Add it to the 124. Great. So 124 plus 28, 152. So 152 degrees is my final answer. Okay? Those aren't the exact numbers that you're going to work with, but it is the exact same procedure that you'll work with. Okay? Let's see. I asked this question the other day, and we didn't know. We didn't know the answer. If I tell you that angle 1 and angle 2 are vertical angles, angle 1 is equal to 4x plus 8. Angle 2 is equal to 10x minus 36. Okay? And I asked, what is angle 1? Where do we begin? What did you say, Cassie? Set them equal to each other. Why am I going to set them equal to each other? Because vertical angles are congruent, which is something that we should be repeating to ourselves over and over and over and over again. Vertical angles are congruent. So we're setting angle 1 equal to angle 2. So 4x plus 8 should be equal to 10x minus 36. Okay? Then it's just a simple matter of solving for x. Okay? So step 1, solve for x. What is step 2? Okay, sub x in, okay, 4x plus 8. Okay, and solve. Do we need to take the time to solve that? I mean, for the review, for right now, basically I want you to know the procedure more than, because knowing the answer isn't necessarily helpful, because it's not going to be the same question on the test. Okay? We need to know two things. We need to know, well, a couple things. We need to know that vertical angles are congruent, so I set them equal to each other, isolate x, solve x, but before I'm done, input x back in and solve. Okay? All right, question number 3. We need to find the distance between 2 points. Okay? Let's try -7, -3, and 3, -4. What do I start with? Okay, we want the distance. Start off with the distance formula. Okay, good. What's the first thing? What's the first big thing in the distance formula? A great big square root. Okay, what's next? Parentheses x2 minus x1. Good. So squared, good. Plus, good. y2 minus y1 squared. All right, what I would do at this point, after I wrote down the formula, is I would come up here and I would label those different things so that I knew what x1 was, I knew what x2 was, I knew what y1 was, I knew what y2 was. Okay, because then I can just drop everything down. Okay, what is -7? x1. What is -3? y1. Okay, so that makes this x2 and y2. Okay? Okay, x2 is 3 minus -7 squared plus -4 minus -3 squared. Okay, what's 7 minus -3? 10. Okay, good. 10 squared plus, what's -4 minus -3? -1. Okay, -1 squared. Okay. What is 10 squared? 100. What is 1 squared, or -1 squared? Okay, so 100 plus 1, I get a square root of 101. Okay? Can I break that down at all? Or will it just stay like that? Probably stay like that. I think 101 is a prime number anyway, so it's just going to be 101. Okay? Now, if that had said 100, right, the square root of 100, what would my answer be? 10. Okay? All right, what are we ready for? 4? Okay. A false truth value. All right. I'm trying to think. Let me give this to you in such a way that you're going to get the most out of it. Okay. Let me pause here for a second. All right, so when we are looking for something with a false truth value, what we are looking for is something that is true but false. Okay, let me explain. We want this first part to be possible, but we want the second part to be false in light of the first part. Okay, but it's got to be that. So we have to have something that is possible in the beginning, but in light of the first statement, it doesn't line up. So it would be like a false conclusion. Okay, so it would be something along the lines of, now they're going to give you more of like a geometric answer, but I'm going to give you kind of like a real world answer. Say, if a horse has 4 legs, then it is a bird. Right? Can a horse have 4 legs? Yeah, that's a false, or sorry, that's a true possible statement. But the conclusion doesn't equate to the hypothesis. Does that make sense? All right. So, they're going to give you some statements where the first part of it is false. It's impossible. Okay? They might say something along the lines of, in the beginning of it, if an octagon has fewer than 8 sides, then let me see if I can see what kind of the thing they go here. Then the sides will be congruent. Okay, this doesn't work. Does anybody know why this doesn't work? Right, an octagon can't have fewer than 8 sides, so the first part of the statement is impossible. Does that make sense? They might start off with something that says, if 2 lines intersect 3 times, then. Okay, well, 2 lines can't intersect 3 times, can they? How many times can 2 lines intersect? Once. Once, never, or they're the same line, right? So by starting off with a statement of 2 lines intersect 3 times, it doesn't even matter what the second side says, because the first side, the left-hand side, is false right off the bat. So what we are looking for is a statement where the first part of it is true, but in light of the first part, the second side of it is false. Okay? Does that make sense? Hopefully I've been clear on that. Okay. So they're going to give you some statements. All right, I at least want to get through the first 5 or 6 if I can. This question goes back to some earlier things. Let's say that we have, you've got line XZ, okay? We've got point Y, not line segment Y, but point Y is on it. Okay. They'll say that xy is something like 6x minus 16. YZ is 10x plus 6. Okay, we want to find x z. Okay? What do I do first with this? Draw it out, okay? So what should I begin by drawing? Draw a line big enough to work with. Okay, I've got a line there. What's the next part? Label it. Okay, so pick a different color here. Where do I begin to label from? The end. All right, so here's an end. What would you call that end point? X. Okay, do we want to label something on the other end? Z. Good. All right, I know this seems really basic and elementary, but if we can't get a starting point together, then we won't be able to know what we're dealing with. Where do I put Y at? Exactly in the middle? No, just somewhere in between. In fact, I'm going to make it purposefully not the middle so that I don't come under the false conclusion that x, y, and y, z are equal to each other, right? Okay, because what would it have had to have said for y to be exactly in the middle? Or would have to have said that y is the midpoint, and it didn't say it, so I can't infer that. All right, so what's next? All right, so put 6x minus 16 between x and y. Is that what you meant? Okay, now what? Okay, 10x plus 6. Got it there. Great. We've drawn a perfect picture. Now we just have to do some math. What are we going to do? Add, right? It's the segment addition postulate. Perfect. Okay, add what? Plus 10x plus 6. Are we setting it equal to anything? No, because they didn't tell us what xz equaled, and they didn't ask what is the measurement of, right? They didn't ask for a measure, they just asked what it is. So now what? All right, combine like terms. What are my like terms? 6x and 10x, which is 16x. Okay, what else? Okay, negative 16 and 6, all right, which is negative 10. And that's my final answer. There's nothing more to that. There's no, xz equals 22 or something like that. That's just it, okay? So it's an algebraic answer. So far, does any of this seem beyond us? Okay, I probably think the hardest question at this point has been probably the false truth value thing, because it's kind of new and we haven't probably worked with it a lot. This next one is, what is the interior angle measure of a regular, let's say, what is the interior measure of a regular, let's pick something fairly large, let's say nonagon. Because the question you're going to work with is going to be smaller than this. Okay, shouldn't be too bad. So this is something right off of our review, right? What is the interior measure of a regular nonagon? So what's our formula? N minus 2 times 180. And they didn't ask what was the measure of each angle inside a regular nonagon. They just want to know what the interior measure is. So that's the same as sum of interior angles. Okay? So N is what here? 9. So 9 minus 2 times 180. 9 minus 2 is 7 times 180 is probably something fairly large. Okay? You guys can figure that out, but what's more important here is knowing to use this formula for this question. If you can remember to use that formula in this question, then I'm not super concerned with that answer so much as you know what to do. Okay? 7, let's see, and we're out here at 45. So I'm going to stop right here. Okay? I'll pick up with the other class from question number 7, and hopefully we'll get through it.